Nico, DC is a hot topic these days. Now, a lot of people will know about AC grids and AC technology. Why do we need DC?
So for sure, we see currently a trend to go to DC because DC had a lot of advantages. For example, also we have a PV. PV is producing already DC.
Correct.
And we also have in your home, for example, you're driving an EV. EV battery is also on DC. And we see this trend also in industry that the produce of the energy in DC goes directly into the application DC. So you don't have the conversion from AC to DC again. And there are a lot of advantages in DC by, for example, reducing the energy consumption, reducing materials like copper up to 50%, but also by integration of batteries, you're able to reduce the peak power up to 80%. And these are all advantages you can handle with DC.
Now, you just announced the SCCB. What does that stand for and what does this do?
So the main difference between AC and DC is that we don't have a zero crossing in DC, and that's why we have also challenges in protection systems.
Correct.
And therefore, our solution is a semiconductor circuit breaker. And with a semiconductor circuit breaker, our protection devices is based on semiconductors, and there the speed is essential because in DC, in case of a fault, you have a tremendous rise of the current, and this needs to be handled within microseconds.
And in terms of the applications, we hear a lot about obviously AI factories, data centers. But in manufacturing, there's also, what kind of use cases are you seeing?
Absolutely. The AI data center are currently focusing on going to DC in their AI factories. They are pushing this topic. But nevertheless, there are also different other applications also in industry to go to DC because the advantages of DC are there the same. And we from Siemens also will build up our new technology campus on DC. We have a logistics building there and an R&D building, and we build it up in DC, and this breaker will also be integrated in these applications.
Now, when you announced the product, you spoke about that this is a game changer. How do you see that? How do you define that?
As I said, we need new protection devices to handle these DC grid, and that's why we think our solution with a semiconductor circuit breaker is a game changer because, first of all, as I said, the speed is necessary for DC grids and that we can provide with such a solution. We also have the topic of bidirectionality. That means a DC grid as a battery can be charged and discharged. Okay. And this can be also handled with our breaker because it's a bidirectional charger. And by the way, you can also see this by the status light. So the direction of the light is also changing.
The direction of the current.
Correct. And this breaker is also equipped with a communication module. So the communication module here can be added. So that means our breaker then also integrates in our existing portfolio about communication with Profinet and Modbus TCP.
So I part of the IT OT convergence, I can connect this up to my management systems.
Correct.
Manage everything.
Yes.
From a central point.
Correct. So the integration in the communication topic is for sure the main use case for such an intelligent breaker, which can be also, let's say, parameterized by you as a customer to your application on your needs.
Hey, yeah, DC is a growing opportunity. There's
absolutely
a massive amount out there. Hey, good stuff. Thank you very much.
Thank you, Kevin.